In this demonstration, we're going to construct a series LRC circuit. That's an inductance, a resistance, and a capacitance. What you see right now on the meter is that we have a 15 microfarad capacitance made up of these two capacitors in series. And we also have a 10.6 millihenry coil of wire. Because it's a winding of wire, it requires a lot of wire, and so there's also a resistance, which we can measure to be about 5.8 ohms. All right, so what we're going to do is then build this series combination of the three. And remember, the inductance and resistance are already in series inherently in this coil. So I'll attach the one terminal of the capacitor to this battery. We're going to charge up the capacitor with the battery through the inductor and the resistor. And we'll do that like this. So we are now connecting the battery to the series combination of the inductance, resistance, and capacitance. And we're going to measure what happens when we discharge the capacitor through the inductance and resistance with the oscilloscope. So I'll connect the oscilloscope to measure across the capacitance, like that. And when I remove the lead from the inductor from the positive terminal of the battery and touch it to the other leg of the capacitance, we'll get the discharge. Now, what we'd like you to do with this information that you have on the scope is to determine how much charge was on the capacitor to begin with. And furthermore, we'd like you to estimate the period and the decay constant for this discharge. So I'll give you some data points on the oscilloscope. So I'll put this cursor right there, and this cursor I'll put, say, right here. And what you can read off here are the times associated with each of those cursors. And the horizontal the time base on the horizontal axis here is 2.5 milliseconds per division. That can help you as well. Vertically, it's 2 volts per division. Something else you should be able to observe from the time dependence of the discharge that you see here is that the circuit is underdamped.